Welcome, everyone. We are thrilled you could join us for another deep dive today.
Absolutely. It's great to be here.
So we are heading into the really fascinating and honestly sometimes kind of shocking world of physical security today.
Yeah, it's an eye-opener for sure.
It really is. Our mission for this deep dive is to explore the harsh reality of safe failures, specifically looking at real-world cases right here in Los Angeles. And we've got a massive stack of sources on the table for this one.
We really do.
We are pulling from professional locksmith documentaries, comprehensive security system guides, highly detailed technical manuals, and this is the best part, actual local LA locksmith service logs.
It's quite the comprehensive collection, honestly. I mean, we'll be looking at everything from the mechanical engineering of lock cylinders to the actual state building guidelines for fire safety.
Right.
And by examining these failures from, devastating fire damage to bizarre digital lockouts, you are going to learn exactly how to protect your own valuables from these incredibly common pitfalls.
Because the core premise we are challenging today is that illusion of the impenetrable fortress.
Yes, that false sense of security.
Exactly. You buy a safe, you put your documents, your jewelry, or your cash inside, you close the heavy metal door, hear that satisfying mechanical click, and you just assume your belongings are completely secure.
But the real-world service logs paint a very, very different picture.
They really do. But before we unpack the mechanics of how these failures actually happen, we should definitely acknowledge today's sponsor, West Point Locksmith.
A very relevant sponsor for today's topic.
Seriously, they are fast, reliable, and highly professional locksmiths serving all of Los Angeles. From emergency lockouts to rekeying, smart locks, and car key replacements, they have incredible 5-star reviews and are available 24/7.
Which is crucial when you're locked out of something important.
Exactly. They are there to keep your home, your business, and your vehicle secure. You can reach them anytime at 310-295-4040. And we'll actually dive a bit deeper into how their experts handle these precise, safe situations a bit later.
Having a professional service like that on speed dial is just crucial because, as our sources reveal, attempting a DIY approach to a locked or broken safe.
Oh, man.
Yeah. It rarely ends well for the safe itself or, more importantly, the contents inside.
No kidding. I mean, seeing a safe opened in under 5 seconds completely upends that whole assumption of security we were just talking about.
So this Sentry Safe video.
Yes, there is a video in our source stack from a well-known locksmith documentary series demonstrating a consumer-grade Sentry Safe being cracked open in literally less time than it takes to tie a shoe.
It's pretty wild to watch.
It really makes you wonder what structural compromises allow that to happen so quickly. I mean, 5 seconds.
Well, the engineering reality behind the product really just comes down to the economics of manufacturing. The technical manuals we reviewed explain this dynamic very clearly.
Right.
A lock mechanism becomes vulnerable for two basic reasons. You've got design shortcomings and manufacturing shortcomings.
And both of those are tied to the price tag, right?
They're directly tethered to the retail price, yeah. To keep prices low on consumer safes, manufacturers have to rely on what engineers call loose tolerances.
Okay, so if tighter tolerances mean better security, why are so many consumer safes built with this wiggle room in the first place? Is it purely just a manufacturing cost issue?
Mostly, yes. Manufacturing at scale demands those compromises. A tolerance is essentially a necessary sloppiness that exists in all machined products.
Necessary sloppiness.
Right. The manual gives a helpful example. If you want a hole drilled to exactly 1/4 of an inch, it will almost never be mathematically perfect.
It's going to be slightly off.
Exactly, by some microscopic fraction. Making it absolutely perfect requires highly specialized machinery and significantly more time.
Which drives up the cost exponentially.
Exactly. So to mass produce these safes and sell them at big box hardware stores for, say, a couple $100, the internal components inside the lock cylinder just do not fit together with absolute perfect precision.
So there's play in the mechanism.
Yes. And a skilled lockpicker knows exactly how to exploit that specific sloppiness. They use that tiny bit of wiggle room to manipulate the pins or the wafers inside the lock.
The wafers?
Yeah, think of wafers like a series of tiny spring-loaded seesaws inside the lock cylinder. They all need to be balanced perfectly flat before the key can turn.
Okay, I can visualize that.
If the manufacturing tolerances are loose, a picker can easily feel the feedback from those seesaws and just nudge them into place one by one using very simple tools.
Wow. And the manual also notes a very fundamental principle of physical security that frames this perfectly. No lock Even a really high security version will absolutely prevent access.
Right. Given enough time, any lock can be bypassed.
Exactly. A safe really only has two basic functions: to make an intruder expend time and to make an intruder make noise.
That's the golden rule of physical security. The more time and noise required, the better the safe. A cheap safe with loose tolerances demands almost zero time and zero noise.
So a thief can literally bypass the lock silently while the homeowners are asleep upstairs.
Exactly.
And that concept of time and noise actually brings us to another massive point of failure, highlighted repeatedly in those Los Angeles service logs we looked at.
Unbolted safes.
Yes, unbolted safes. People buy these heavy steel boxes, slide them into the back of a closet, and just leave them sitting freely on the carpet.
Leaving a safe unbolted is perhaps the most common critical error a consumer makes. If a safe isn't bolted into a concrete slab, or at least securely fastened to the heavy structural framing of the building, its purpose is entirely defeated.
Because of the time and noise rule.
Exactly.
Hmm.
Applying our rule, if the safe is free-floating, the burglar doesn't need to expend the time and noise required to pick the lock or pry the door open while they're inside the home.
They just bypass the locking mechanism entirely by taking the entire box.
Yeah. Thieves simply throw a moving blanket over it, strap it to a hand dolly, wheel it out to a waiting van, and they are gone in under 2 minutes.
It's terrifying how easy that is.
And once they have the safe secured in a remote location, say an empty garage somewhere, or out on a desert road near Joshua Tree, they have unlimited time.
Right, they don't have to worry about noise anymore.
Exactly. They can spend the next 5 hours using angle grinders, plasma cutters, sledgehammers to get it open, making as much noise as they want without any fear of neighbors calling the authorities.
So the major takeaway for you, the listener, is that purchasing a heavy box and sliding it under a desk offers a total false sense of security. Without heavy-duty concrete anchors, you have essentially just purchased a convenient carrying case for your most valuable possessions.
Perfectly said. So we've seen how physical metal can fail due to manufacturing shortcuts or installation errors. But adding digital technology to the mix creates an entirely new set of blind spots.
Oh, the digital lockouts.
Yeah.
Yes. The sources contain a fascinating real-world story extracted from a documentary series by Wayne Winton.
He's a very prominent safe technician.
Right. And this involved a very classic LA-style service call.
The disintegrated battery pack case.
That's the one. So the customer was completely locked out of their digital safe. They punched in their code and the keypad was completely dead.
Just unresponsive.
Totally. The electronic battery housing on the outside of the door had degraded, and the internal wires connecting the power to the lock were physically broken. But the fascinating part of this story is that the customer wasn't panicking at first.
Because they had the physical backup key.
Exactly. They assumed the physical key would save them.
And this is where the customer's assumption collided with the mechanical reality of how certain dual lock safes are actually engineered.
Right, because it wasn't what they thought it was.
No. They assumed the physical key was an override lock, meaning a completely separate mechanical pathway to retract the bolts if the electronics ever failed. But on this specific consumer safe, the key was not an override.
It was a secondary lock, which serves a completely different function.
Entirely different. It is a key block system designed for a specific type of access control. Turning that physical key mechanically locks the boltwork in place, regardless of what the electronic keypad is doing.
So even if the electronics were functioning perfectly and they punched in the correct digital code, the safe wouldn't open if that key lock was engaged.
Correct. Manufacturers actually design it this way so that a business owner can give an employee the digital code for daily operations, but still physically lock them out over the weekend by just turning the key.
Oh, that makes sense for a business. But for this homeowner, because the electronics were dead, the key was entirely useless for gaining entry.
It just locked an already locked safe.
Exactly. So the way the locksmith fixed this issue required some incredible improvisation.
It really did. Fortunately for the technician, the client owned 2 identical safes sitting right next to each other.
Talk about lucky.
Very lucky. One had a broken battery pack, but the other one was functioning perfectly, which provided a working template right there on site.
Right. So the technician carefully took the working battery pack from the good safe and essentially hot-wired the broken safe. The documentary showed them using these tiny connectors called low-voltage beanies to splice the connection.
Yeah, beanies. They are essentially tiny plastic wire connectors filled with a moisture-resistant gel. You slide the broken ends of the conductive wire inside, crimp them down with pliers, and it creates an instant secure splice.
It's so clever.
It is. By bridging those broken wires, the technician successfully powered up the safe's internal electronic lock, just enough to accept the digital code and retract the bolts.
While clever, it definitely highlights a major vulnerability for the average consumer. We all love the convenience of keypads and biometric fingerprint scanners, but they introduce a really heavy reliance on power and consistent maintenance.
They absolutely do. Electronic safes are highly vulnerable to environmental factors that mechanical dials simply ignore.
Like dead batteries.
Dead batteries are the most frequent culprit by far, but consumers also have to worry about power surges frying the internal circuit board.
Right.
There is also the risk of user error, where someone types the code incorrectly too many times and triggers a permanent digital lockout. And over time, physical corrosion of the battery contacts due to humidity can also sever the power connection completely.
It really makes you rethink relying entirely on a digital keypad for a safe you might only access once every 5 years. I mean, by the time you urgently need your passports or property deeds, the alkaline batteries could have leaked and turned into corrosive dust.
Exactly. Anyone relying on these systems needs to know the exact maintenance schedule for their safe's electronics. A digital safe functions essentially as a small computer attached to a heavy steel door.
It's not just a metal box anymore.
No, it requires proactive battery replacements and climate control to ensure the internal circuitry remains intact.
Dealing with all of these potential disasters, from the loose mechanical tolerances we talked about to fried circuit boards, is exactly why having a true professional on call is non-negotiable.
You do not want to be taking a power drill to your own safe because you forgot the code.
Or because the battery contacts corroded. This is exactly where our sponsor, West Point Locksmith, becomes an essential resource. They have 5-star rated experts serving all of Los Angeles who handle everything from proper safe installation and heavy-duty concrete bolting to emergency access, combination changes, and specialized vault maintenance.
They really cover it all.
They do. Whether you are dealing with a residential fire safe or a commercial high-security vault, they are available 24/7. Again, you can call them at 310-295-4D40 to secure your peace of mind.
And detailing exactly how professionals like the team at West Point approach a safe lockout reveals a highly specialized skill set.
Oh, I bet.
When a failure occurs, a certified professional focuses entirely on non-destructive methods first. The primary goal is to retrieve your valuables while preserving the structural integrity of the safe so it can remain in service.
I am actually really curious about how they bypass a mechanical combination dial without causing damage. The movies always show someone with a stethoscope listening to the door, but what is actually happening inside the mechanism? Is it really just sound?
The stethoscope thing is a bit of Hollywood exaggeration. The primary non-destructive method for combination dials is called manipulation, and it truly is an art form.
So it's more about feel than sound.
Exactly. The technician uses their highly trained sense of touch and occasionally some specialized amplification equipment to feel the internal mechanisms interacting. Inside the safe door, connected to the dial, there is a wheel pack.
Okay.
Each wheel corresponds to a number in the combination, and each wheel features a tiny indentation or notch.
So the goal is to get all those individual notches lined up perfectly so the internal locking bar can drop down into them, allowing the main bolts to retract.
Precisely. By applying slight rotational pressure to the dial and feeling for microscopic points of resistance, a skilled technician can deduce the location of the notch on each wheel.
That is incredible.
They decode the combination systematically without ever drilling a single hole. It requires immense patience and an intimate understanding of the lock's internal geometry.
Wow. And for key locks, the approach shifts to exploiting the manufacturing flaws we discussed earlier.
Yes. Professionals use highly specialized lock-picking tools to lift each individual pin or wafer inside the cylinder to the exact microscopic height required to turn the plug.
The sources also detail a method called bypassing. How does that work?
Bypassing involves exploiting specific architectural design flaws in certain safe models.
So not the lock itself.
Right. Instead of attacking the lock cylinder itself, the technician uses specialized tools to reach through tiny gaps in the safe's body to manipulate the internal locking mechanism directly. They completely bypass the dial or the keyway altogether.
But there must be scenarios where those non-destructive methods simply fail, right? If the lock is internally rusted, physically damaged from a burglary attempt, or it's just a super high security safe designed specifically to resist manipulation, what is the protocol then?
In those cases, professionals move to destructive methods, but only as an absolute last resort, and the process is highly calculated.
They don't just take a sledgehammer to it.
No, they do not just destroy the door with brute force. They use precision drill rigs that mount magnetically to the front of the safe.
And they consult detailed engineering blueprints of that specific safe model to find the exact coordinates of the internal locking mechanism before they ever start drilling.
It is an incredibly surgical procedure. They use specialized diamond or carbide-tipped drill bits to create a tiny access point, often no wider than the diameter of a pencil.
Just a tiny hole.
Yes, and through that tiny hole, they insert a borescope,
Which is like a little camera.
essentially a specialized medical camera adapted for metalwork. It allows the technician to look directly at the internal wheel pack on a monitor and manipulate it open.
That's wild. And once the safe is open and the contents are secured, they can just plug that small drilled hole with a hardened steel pin, right?
Exactly. The safe is often returned to service just as secure, if not slightly more secure, than it was before the lockout.
So when do they actually cut it open?
Cutting the safe open with demolition saws or thermal torches is reserved solely for catastrophic mechanical failures, where the safe is already deemed a total loss.
Makes sense. Okay, shifting our focus away from mechanical lockouts and burglars, we need to address environmental disasters.
Fire.
Yes, fire. People frequently purchase safes to protect their birth certificates, their property deeds, and family heirlooms from burning up in a house fire.
And the threat of fire exposes some of the most tragic misunderstandings of what a consumer safe can actually withstand.
The data on this is wild.
It is. Looking at the state building guidelines and the Los Angeles Department of Building and Safety testing parameters, the data reveals a startling statistic. A standard residential structural fire could easily reach over 1,000 degrees Fahrenheit in less than 5 minutes.
Reaching 1,000 degrees in under 5 minutes leaves almost no margin for error. And this leads to a massive consumer misconception. People walk into a hardware store, see a heavy box with a sticker of orange flames on the front, and just assume the product is entirely fireproof.
The term fireproof is a marketing myth.
Completely.
Safes are, at best, fire resistant. They undergo rigorous testing and are rated based on 2 distinct factors: the duration of time they can survive and the external temperature they can withstand before the internal temperature rises high enough to combust paper.
And paper spontaneously combusts at roughly 451 degrees Fahrenheit. So the safe's primary job during a fire is to keep the internal chamber below that critical threshold, while the exterior is just engulfed in an inferno.
The mechanics of how they achieve this are quite interesting, actually. Many fire-resistant safes are lined with layers of gypsum board.
Like drywall.
Exactly like drywall. Gypsum naturally contains moisture. As the exterior of the safe heats up, that moisture turns to steam and is released into the interior chamber,
Okay.
which actively cools the inside and helps seal the door gaps against incoming smoke.
But that cooling mechanism has a strict time limit.
A very strict limit.
These fire ratings typically range from 30 minutes to 2 hours. A standard affordable home safe might only carry a 30-minute rating at 1,200 degrees.
To contextualize this for you, the listener consider a scenario where you place a 30-minute rated safe in the basement or interior closet of a wooden-framed house here in Los Angeles.
Which is very common.
Right. If a structural fire breaks out or a wildfire sweeps through the hills, the fire might burn intensely for 3 or 4 hours before the fire department can fully extinguish the flames and the surrounding debris actually cools down.
In that scenario, the safe will inevitably fail.
It has to.
Once the gypsum expels all its moisture, the internal temperature will spike rapidly, and your irreplaceable documents will literally turn to ash inside a locked metal box.
The safe effectively becomes a specialized oven.
That is a brutal way to put it, but it's true.
When selecting a safe, you have to realistically assess the average fire response time in your specific neighborhood, the building materials of your home or office, and exactly where the safe will be located. A 2-hour fire rating provides a significantly wider margin of safety than a 30-minute rating.
Misunderstanding the limits of that rating is a very fast way to lose everything you were trying to protect.
It's a sobering reality.
It is, but exploring these vulnerabilities is exactly why we do these deep dives. We want you to be informed and prepared long before a disaster ever strikes.
Absolutely.
Distilling the ultimate lessons from all of our sources today leaves us with a few vital takeaways. Number 1, do not rely on a cheap, unbolted safe to protect high-value items. If a thief can lift it, they will simply carry the locked box away. Always anchor your safe directly to the concrete slab.
Number 2, if you opt for the modern convenience of a digital keypad, you must actively maintain the batteries and treat the safe like the sensitive electronic device it is. Furthermore, understand exactly how your specific mechanical override systems function before you actually need to use them in an emergency.
Know if it's an override or a key block.
Yeah.
Number 3, closely read the fine print on your fire ratings. Know the exact duration and temperature limitations your safe is rated for, and plan your document storage accordingly.
And finally, if you ever find yourself facing a mechanical lockout, a dead battery pack, or if you simply need a high-security installation done properly the first time, you need to call the professionals.
Yes. A huge thank you once again to our sponsor, West Point Locksmith. For any 24/7 emergency lock, safe, or car key needs anywhere in Los Angeles, you can reach their 5-star team at 310-295-4040.
To leave you with a final, provocative thought to mull over. When you lock your valuables away tonight, consider what you are truly relying on. Are you genuinely relying on robust mechanical engineering and professional installation? Or, if you have an inexpensive unbolted box sitting on a closet shelf, are you really just relying on the hope that a thief is more impatient than you are?
Oh man, that is a question that will definitely make you audit your own security setup tonight.
Yeah, I'm checking mine.
Same here. Thank you so much for joining us on this deep dive. We hope you walk away feeling more well-informed, significantly more secure, and ready to take your physical security seriously. Stay safe out there, and we will catch you on the next deep dive.